Hey everybody, thank you for joining us today. It's appreciate everybody showing up on a snow day, especially our speaker, who we're not giving a break to today. She's been meeting with some faculty this afternoon and then is happy to still be able to present to us at our usual time frame. Our speaker today is Dr. Megan Schargorodski. She's the interim director of the Kentucky Climate Center and state climatologist for Kentucky. She has a Bachelor of Science in Meteorology from the University of Oklahoma and a Master's of Science in Homeland Security Sciences with a concentration in Emergency Management Disaster Science from Western Kentucky University. Megan has nearly 20 years of experience in working with weather networks, including 15 years with the Kentucky Mesonet at WKU. Her research interests lie in meteorological instrumentation and applied climatology, meteorology, with applications in disaster science and the emergency management process. Megan, thank you very much for joining us today. And with that, I'll let you take it away.
Thank you for the wonderful introduction, Rebecca. I am going to turn off my camera just so that I don't run into any bandwidth problems. Is that okay? All right.
Yep.
All right, so let's get started. Thank you so much for, again, being here at 3 p.m. on a Friday, which is whenever you always have seminars, but I know that university is closed today, so I appreciate you taking the time to be here. So as Rebecca said, my name is Megan Schargorodski, and I'm with the Kentucky Climate Center. And today I'm going to talk with you about farm scale weather monitoring with the Kentucky Mesonet, and giving you just a little bit of a background on what the Kentucky Mesonet is. So first and foremost, I like to start off with saying who we are, because yes, we are a physical network, but we are also the people behind it. So we have 8 full-time staff as well as 10 undergraduate students at the Western Kentucky University. And we have people who go out in the field. We have people who look at the data, create the cyber infrastructure for our website and all of that, as well as all of us join together and doing outreach events. And so we all come together, we all know each other's jobs, and it is a really wonderful family of people at the Kentucky Mesonet. And so again, I wanted to start off by showing the faces behind everything. Going back, this is a Kentucky Mesonet timeline. Back in 2006, we got a National Weather Service federal earmark through Mitch McConnell's office, and that established the first about 45 to 50 stations of the Mesonet, as well as the initial staffing to get everything started. In 2006, we also had the Kentucky Senate Joint Resolution 228, which established the Kentucky Mesonet as the official source of climatological data for Kentucky. And then as we move forward, we were able to install the first station in May of 2007, and that was at the Western Kentucky University Farm in Bowling Green. Then as we moved into 2008 to 2015, we grew the network. We really focused on getting stations out there and building those local relationships. In 2016, we were able to establish a state appropriation through the Western Kentucky University budget. And we have been incredibly thankful for that, because it gave us that springboard into all of the advanced products and applications that we can move into. We were able to hire a few more staff members, and we were able to develop more advanced products. As of late 2021, our full Mesonet station count is at 76, and it services 73 counties. We expect about 3 new stations in 2022, and then about 10 to 15 more in the next few years. So where are the Kentucky Mesonet stations? We expand across the entire state. We have station over in Fulton County in the very far west, all the way up in Campbell and in Boone County in the north near Cincinnati, all the way over to the east into Appalachia, and all across southern Kentucky as well. So again, we have a pretty good coverage. The red dots are the current Kentucky Mesonet stations. The yellow dots are the pending stations. And some of you may be very happy to see that there is a yellow dot in northern Fayette County. And I'll talk about that a little bit more in a little bit, but that's a really exciting one. And that's basically the reason why I'm here today. So what is on a Kentucky Mesonet station? These are 10-meter towers outfitted with sensors to measure standard weather variables at all of the stations. And this includes air temperature, precipitation, solar radiation, relative humidity, wind speed and direction, and barometric pressure. And again, those are at all of our stations. We do have a handful of select enhanced stations, and this includes soil moisture and soil temperature, multi-level temperature and wind speed, and landscape weather camera imagery. And so while our soil sensors tend to be at quite a few more stations, the others are at a much smaller subdivision of the stations. So we'll talk about that a little bit more in a minute, but these standard weather variables are measured every 1 minute and returned to the Mesonet Operations Center in Bowling Green every 5 minutes with cellular communications over AT&T network. In times of active weather, the data collection frequency can be modified to observe that 3-second sample, which gives us a very high resolution of the real-time conditions that are happening. This came in very, very handy whenever we had the December severe weather outbreak across Kentucky. We were able to look at that data basically as it was happening at the station instead of having to wait that 5 minutes to get the data. So it was a very, very handy application. One thing with all of our Mesonet stations is that we try to make sure that the stations are located in an area that is suitable for World Meteorological Organization standards. A station by their standards is in a perfectly flat plain with nothing around it for a while, no trees, no buildings, no nothing. Well, Kentucky is not a flat state and does not have cleared obstructions. So we have, as we are looking at individual stations, we have to take the local terrain and geography into account. We have to make sure that it is representative and that it is reflective of what needs to be represented in that area. On the right side of this slide is an example of the vertical profile of our stations. Again, we go up to 10 meters high, but we also go about 1 meter below the surface as well with our soil sensors. So now that we have all of this data, what do we do with it? The first step is making sure that it is good data. If we have a whole bunch of bad data, it doesn't really help anyone. So we have dedicated staff that looks at every single data point that comes across the network. And so if they notice that there is something wrong, they will go into our quality assurance system and flag the data. And this means that it will either be marked that maybe this is not good, but we're going to think it's okay, we'll keep an eye on it. Or it could be as bad as, yes, it is not 500 degrees outside, there's something wrong with this temperature sensor. So as we look into the data more and more, we are able to get a better grasp of what kind of things could be the problem. If it comes back to a certain sensor, then the quality assurance analyst will issue what is called a trouble ticket, and it will trigger for the field technicians to go out to the station. Talking about the field technicians, so station maintenance is another very vital part of the quality assurance process. These stations are visited every spring, summer, and fall, so at least 3 times a year. Sometimes it's more whenever there are problems that happen, as I suggested on the last slide. So these 3 times a year that they go out for regular maintenance, they are checking the instrumentation to make sure that it's inside of the shield that it needs to be, making sure that it's clean. They're out in the environment, so there's a lot of things that can happen. The vegetation that is natural to the area, we have to make sure that it is not too high or not too low. It has to be in somewhat of a sweet spot of representative vegetation for the area. And they also take pictures whenever they go to these stations so that we can see what the conditions are when they were there and what the conditions are when they left. And this gives us a baseline to where if we notice that a temperature sensor, for example, is reading high, but then when they've cut the vegetation, it has gotten lower, then it's tied to the vegetation cover as opposed to the sensor itself. So all of these are very important in the grand scheme of quality assurance. Another key factor in quality assurance is the metadata database. So metadata is the data about data. And so from the very beginning of the Kentucky Mesonet, we've been very, very intentional of making sure to record just about everything we possibly could. We knew that we needed to keep track not only of the station metadata, which is the information like the site location, the type of surroundings that it's in. We also knew that we needed to keep track of the sensor metadata and the equipment metadata. And that meant keeping track of where that sensor has been, when it was calibrated, if it was ever damaged, and so forth. And so we tied all of this information together in a metadata database, and we were able to utilize this to further the quality assurance process of making sure that we have the best data out there we possibly can. It also gives us a trigger if the sensor if it's been too long since the sensor has been calibrated. It will give us a notification that says, hey, you need to swap out this instrument so that you can get it calibrated. Now that the data set is quality assured, now it's ready to go out to the public. So we have two main portals of public data access. We have our main website on kymesonet.org, and then we also have phone apps, and they are available both on iOS and Android. So looking at our main website, this is where all of the data maps happen, and that select map drop down on the left, you can change the map to precipitation, relative humidity, solar radiation and soil temperatures, and the whole variety of weather variables that we have. You can dig into the top menu just a little bit, and we'll go into some of those in a minute. And there's more data that is available there. On the right, again, the phone app, it is a very simple and very quick way to find out what the temperature is at your nearest or favorited Kentucky Mesonet stations. There is a location service available to where you can be anywhere in the state, and it will take where your location is and find the closest station. So it takes a little bit of that guesswork out for you if you're in an area that you're less familiar with. You're also able to save stations. So if you have farms in multiple areas across the state, you can save the Kentucky Mesonet station for that county and keep it. You can see on the bottom there are little circles, and you're able to swipe through the different Kentucky Mesonet stations. And so it's a great tool to have. You also have the National Weather Service forecast at the bottom, and I look at it every morning when I'm getting ready. I'm able to see what the temperature is as I'm leaving. I'm able to see what the expected high is, and it's been really great. Also on the background, you can see there are clouds. The background will change based on what the weather is outside. So if right now, if it's snowing at that location, it'll have little snowflakes in the background. So just a little fun tidbit about that. So digging a little bit more into the types of data we have available past that home screen, we have graphs of our 5-minute data, and this is available at multiple time intervals. You're able to go back 1 month. I will give you a heads up that if you do choose that 1 month period, it will take 30 seconds or so to load, just because it is a lot of data points. But you're able to change the different type of variables based on the left. You can do temperature, wind, moisture, and so forth. And you're also able to change what the station is. On the right-hand side are two examples of our summary tables. We have monthly summaries, which are basically daily summaries aggregated, and then at the bottom is the monthly climatological averages. And then on the bottom right is our yearly summaries, which is basically the monthly summaries aggregated by station into this table. So you're able to select different variables and different years, and it just gives a very nice quick snapshot of that monthly precip total or the monthly maximum temperature or whatever you're looking for. So one thing I will do a little plug for is that as you're looking through our data, if there is ever a product that you wish we had, I welcome you to get in touch with us, because we are currently working on developing that suite of products, and knowing what would be helpful for you is everything we need to be able to continue doing what we're doing. So another thing that's available in our drop downs is our soil monitoring. This on the bottom right is a picture of the map that's available on the homepage. And on the next slide, I'll have a picture of the graphs. But I wanted to talk about this just for a minute, because naturally you're the Plant and Soil Sciences department, so I thought you might be interested. So we have soil monitoring probes at 60 stations. And at those 60 stations, we have 5 depths. We measure at 2 inches, 4 inches, 8 inches, 20 inches, and 40 inches below the surface. And we use the Stevens hydroprobe sensor, which is a digital sensor that measures soil moisture, soil temperature, and then a handful of other variables that we collect, but we don't do anything actively with. I think soil salinity is one, as well as soil conductivity. Ideally, we would have soil sensors at all of our stations. However, because of the soil composition at some areas, only about 3/4 of our network will have soil probes. These are our soil graphs. On the left is soil moisture, which is percentage of water fraction by volume. And on the right is soil temperature. And we measure it in Celsius, we convert it to Fahrenheit. I also want to note that this is not current data. It is not 100 degrees outside, but it's from the summer of 2018. And it gave us a very, very noted temperature profile. And so you're able to see those clear differences of how it's warmer near the surface and how quickly it responds to the diurnal cycle. And then you have the 40-inch, that is the orange line, that is much more steady and steadfast. And then on the left, you can see the response for whenever there was a rain event, and then another smaller rain event that happened. Another aspect of the Kentucky Mesonet that I think would be of particular interest to this group is near surface temperature monitoring. And this will be the main focus of the second half of my talk. But I wanted to give it a little bit of background on it. So this was a pilot project supported by the USDA Midwest Climate Hub. And they gave us funding to procure sensors at 0.5 meters, 2 meters, and 3 meters, in addition to our existing instrumentation suite. And so on the left, you can see that there is a pretty noted difference between the 0.5 meter temperature sensor as well as the 2 and 3 meter are pretty close to each other. We had some problems with the 0.5 meter sensor in Kentucky. We've had several of them flood because Kentucky just apparently tends to flood a lot at our stations more than we thought. So as a result of that, we have not expanded the 0.5 meter to additional stations. However, we did add a 9 meter temperature sensor. So whenever we are looking at near surface temperature inversions, we are looking at that 2 meter and 9 meter. And again, I'll talk about that in a little bit. So this is at about 25 stations right now. However, I do expect that the 2 meter the 2 meter is a standard measurement. The 9 meter will be expanded across other stations. One of the reasons why this was initially funded was because of the growing interest in temperature inversions and spraying, in particular with dicamba. And so as a result, we've been able to expand this, and we look forward to moving it forward a little bit more in the future, as well as any sort of further products that come out of it. One more thing that we have are webcams. And this not only provides a visual picture of the conditions, it also provides an infrared image that is able to calculate an NDVI image. And this provides a good baseline for vegetation health. And this has been incredibly interesting to watch. Not only in these open fields like this, but also in crop fields, you're able to get a very distinct difference in what is growing well versus what is not growing so well. We initially had these webcams for the long-term climatological context, but then once the NDVI imagery was developed, it's brought a whole new level of drought impact monitoring, as we're able to not only see the visual of it all, but we're also we have that data point of precipitation and temperature and all of that goes into the full picture of what's going on in this location. So now that we've talked about what's at our Mesonet stations, I want to move over to the types of projects that we are able to do. Some of the projects that we've done have been part of existing infrastructure. Some of it has been expanding infrastructure. So the first very fun one that we got to do was the total solar eclipse of 2017. We knew that this was going to be transecting Kentucky. We knew that we had stations that would be within this path of totality. So expecting this, we proactively changed out all of our pyranometers, our solar radiation sensors, and did that across the entire state. We made sure that everything was within calibration, and even more so than normal. We were very particular because we knew we wanted to have a very highly respected data set. And so as a result, on the day of the eclipse, we took the 3-second samples from the sunrise at the earliest part in eastern Kentucky to the latest sunset in western Kentucky. And those 3-second samples were for air temperature, solar radiation, wind speed, and wind direction. And as a result, we get this graph. This is from Christian County in western Kentucky. And this was basically the Hopkinsville area that everybody was flocking to from across the US. And so we have this data set where we can very clearly see the curve drop down to 0 as we reach totality. And we also have this temperature response as well. And this is solely due to totality. There was no other cloud cover. There was cloud cover in the parts outside of totality, but as totality was happening, it was a very, very clear signal. So we were really excited. We were able to have a publication in coordination with the University of Alabama, Huntsville, and it was a very, very neat experience. We look forward to doing it again in a couple of years. It will be a slightly different transect across Kentucky, but I think we have some lessons learned from that experience, and we look forward to doing that again. And so I mentioned this one just because I want to reiterate that we are not just a fixed system. We are able to be very malleable to what is going on. If there is a certain weather event, we're able to pivot and focus on that and be able to to gather that really high resolution data set as it's happening. So one partnership that has been growing over the past year or two is the partnership with the U.S. Forest Service and Daniel Boone National Forests. So we had an existing relationship with the National Integrated Drought Information System, otherwise known as NIDIS, and we knew that there was an interest in soil moisture monitoring in a forest. So we were able to bring all of these parties together, and we gained funding through NIDIS, and we are working with the U.S. Forest Service and the Daniel Boone National Forest. And all of these groups are coming together to build a very dense soil monitoring micronet in the Daniel Boone National Forest. We have two areas that we are focusing on. There is the Cumberland Ranger District in the northern end of the Daniel Boone, and then there is the Redbird Ranger District in eastern Clay County on the southern end of everything. And with these two locations, we are going to be installing about 150 soil sensors. And between all of these, we are going to be looking at different areas. We are going to be one of the locations, the Redbird Ranger District, is going to be based off of the Peabody area, and it is going to be going down and around this hill, and it will provide different aspects and different soil types in that area, as well as what is pictured here is actually going to be at the Cumberland Ranger District. And this is going down from a higher area down into an ephemeral stream and across, and we're going to be able to get those different aspects covered. And so at every one of these nodes, we are going to have at least 5 sensors going down. And again, these are going to be coordinated with our standard Mesonet depths so that we are able to not only compare these sensors to each other, but we are going to be able to compare them to our base Mesonet station that we are also installing, as well as any of our other Mesonet stations. And so all of this will come together into a really cool project that will further the understanding of soil monitoring in a forest. It is a pilot project, and so we are establishing the best practices of what needs to happen, as well as we are also intending to have an instrumentation test bed. So we will have a small area where we're able to put different types of sensors in the ground, and we'll be able to see how their responses are. And as a result, we'll have a better idea of what works well in a forested terrain. This micronet will probably, it should be installed the first half of this year, but the data access will be a little bit later than that. So as a result of all of this, we've been able to have multiple local partnerships. That is the meat and potatoes of the Mesonet. We've really wanted to not only just have the infrastructure, but we wanted to have these local connections and have some importance to the people of a county. So this is Shelby County. After a notable significant weather event a handful of years back, the former judge executive, Rob Rothenberger, wanted to have a weather station in every quadrant of the county. Shelby County is kind of a big county, if you're not familiar with it, so it was somewhat reasonable. We already had 2 weather stations, Kentucky Mesonet stations in place, but the emergency manager applied for a FEMA hazard mitigation grant to install the 3rd station in the southeast quadrant. And so the pictures here kind of show the culmination of that grant and that partnership, and it was approved, and it was a really beautiful story to tell that we were able to get this station. So Many of you have mentioned this as I've talked with you. Yes, I had an initial conversation with Dr. McCauley at the end of last year, and we are hoping to bring a Kentucky Mesonet station to the Spindletop farm. On the right is the existing Mesonet station for Fayette County, and that's at the South Farm. It was installed in 2008. And I do want to throw out a fun fact that it is one of the only 2 stations in the state that has a snow depth sensor. Many of you, I'm sure, are aware of the discrepancies of snowfall measurements. And so that is the reason that one has that. So we are really excited for this opportunity. And again, this is the main reason I am here. After these initial talks with Dr. McCauley, there was, we talked about all the different possibilities there was of farm scale monitoring. And so I hope that when I get to that in a minute, it's of particular interest. When we visited last fall, we decided that the area on the northern end of the farm where the historical weather monitoring stations have been would be the best location. So fingers crossed all of that falls in line and we're able to get that out there before the growing season starts. Another UK partnership that I wanted to talk about for just a minute was the Robinson Forest partnership that we've had. This is a resulting partnership and sponsorship from Chris Barton, and the station on the left is located at the camp in the valley, and there isn't really great coverage for cell signal there, so we have to shoot the data up a mountain, and it goes up to a ridgetop tripod, and from there it's able to send the cell signal. This has a cell signal to send the data out. We do have a couple of small sensors on that tripod, and that has been really cool to be able to see that difference between the two. In addition to those, we also have one over in a reclaimed strip mine, and one of the cool things that we've been able to see from that one, we have a webcam that's out there, and there was recently a controlled burn that we watched as the flames went across the area, and so thankfully it did not damage our station, but it was definitely something fun to watch. Another UK partnership that we have had is Ballard County, and I want to throw out another thanks to Brad Lee for the resources necessary to collect and process the samples that helped us figure out where we wanted to place the station. So the reason it was of particular interest is because of the type of soil, and I'm probably going to say it wrong, but I know that you guys are the experts on that, but the idea was that we would have both sodic and non-sodic soils, and looking at seeing how the soil temperature and soil moisture differ between the two. And so by the data collection that Brad was able to do, we were able to place our station in an area that was representative for us, but it also allowed us to put out 2 sets of soil probes. And again, this goes at our standard 5 depths, but it also allowed us to do one in the 2 types of soils. So we just got those installed in November, I believe. So we are still working through our data set, and unfortunately our sensors do not like when there is frozen soil. So once we get into the spring and the summer, I'm hoping that we're able to investigate that data just a little bit more. So this isn't exactly a direct UK partnership, but it is at the same time. So I wanted to talk about this for just a minute. This last project I'll mention is the Kentucky Drought Early Warning System project. And this was another project that was funded by the National Integrated Drought Information System, or NIDIS. And it was geared toward providing early warning of drought. There were 4 focuses of this project. And on the upper right, you'll see that that's our soil sensor. So we had the expansion of soil monitoring to 10 additional Kentucky Mesonet stations, the development of a data dashboard where you're able to really dive into the data and arrange it and make it useful for what you're trying to figure out. And then a story map of the 2012 drought, and then more than anything, a monthly webinar. And this has been ongoing for about three years now, I believe, maybe 4. And Matt Dixon of the UK Ag Weather Center has been a faithful presenter, and John Strang actually came along as well one time, and it has really added a lot of depth to the outreach component, not only of this project, but of the Kentucky Climate Center as a whole. So I really am thankful that this has been successful. We are still doing it monthly. If you have any interest in listening in, get in touch with Matt, or you can get in touch with me for the link. And I do want to state too that the UK Ag Extension agents are our main audience. And so we're happy that we're able to be disseminating this information out to people across the state. So now on to the main focus of all of this, and this is the details of the farm scale weather monitoring. So we received some funding for a data set from Bayer Crop Science and Climate Corp. And so as a result of that, we were able to establish 4 additional stations on 2 university farms. On the left-hand side is the Western Kentucky University Farm in Bowling Green, and on the right is the University of Kentucky Farm in Princeton. And so Bayer was particularly interested in this near surface temperature inversion and how it impacts drifts, mostly with respect to dicamba. But overall, drift is not a good thing generally. So for now, these stations are very basic stations, and they only measure multi-level temperature at this 0.5, 2, and 9 meter, as well as multi-level temperature or wind speeds at both 10 meters and 2 meters. And these are simple stations only because of a nearby mesonet, full mesonet station. So we're able to supplement these stations with the precipitation and solar radiation and so forth that's at those other base stations. So looking a little closer, I just wanted to bring this data to the screen. You don't really care about the Latin lawn, but the elevation is a little bit interesting. So the WKU farm is relatively flat. There isn't a whole lot of elevation change as you're going across it, especially in between these stations. However, the University of Kentucky farm in Princeton does have quite a bit of change. And so you have 480 feet versus 640 feet between those high and low areas. And so that does play a whole lot of, it makes a big difference as we are looking at temperature inversion data. Here's an aerial view of the WKU farm, just to give you some spatial reference of how things are set up. Again, the area is relatively flat. There isn't a whole lot of change. And this is a terrain map. It's a little deceiving because of the colors, but there isn't, again, very much difference. It's about maybe 10 meters, not even 10 meters, 5 meters difference between the high and the low points here. And I bring that up just to bring a little bit of contrast to these this area and the Princeton area. So the PRNC down in the bottom is the main Mesonet station. And unfortunately, this also has the education center in the image because that's what all of this is centered around. And so you have PNCC in the upper left and PRCC on the right. And then looking at the elevation differences, you can really see that difference. And this color scale is much more appropriate for these. So you do have these lower points at PNCC and then going up on a ridge on PRCC on the right. So the periods and definitions that I would like to establish as I move forward into this initial research. These stations have provided a great data set for the initial research. That is what we're moving forward into. Our research scientist, Dr. Eric Rappin, has been investigating near surface boundary layer evolution and has included all of this in his research. These initial data analysis data sets focus on the 12 months of the WKU farm and 6 months for the UK farm, only because of when they were installed. So as we move forward, we're going to be able to have a larger data set for reference. The strongest temperature inversions generally happen in that 4 hours before and 6 hours after sunset. So those are the times of day that are being constrained as we're looking at this. Initially, this was going to be a comparison between the 0.5 meter and 9 meters so that you get that right next to the surface and then higher up measurements. However, like I mentioned, the 0.5 meters were not sustainable with the network. So we've moved this to the 2 meter temperature sensor and 9 meter temperature sensor. These inversions are further classified based on the strength, and the threshold values are 1, 2, 3, and 4 Celsius. So looking at the WKU farm inversion frequency, again, this is a relatively flat area. So you'll notice that especially at the 1 degree Celsius mark, you don't see a whole lot of difference based on the location. However, as you get farther into the larger threshold, particularly the 4, you're able to see that the first 2 stations that are at the slightly higher elevation have less of a percentage of these inversions. However, that one that is at that slight low point does have an increased percentage that it exceeds that 4 degree Celsius mark. Diving just a little bit deeper into an example, this is from November 4th of 2020, and we're able to get a very clear picture of what's going on. So there was rapid cooling about 1 hour before sunset, and then about 1 to 3 hours after sunset. So all 3 of these stations have some similar characteristics. The afternoon relative humidity values were below 40%, and there was a relatively dry environment for inversion development. The relative humidity changes mirror the changes in temperature because there was weak advection, which basically weak winds. And the wind direction is southerly and persistent for the roughly week-long period surrounding the event, which isn't pictured here, but the inversions were happening nightly. However, this was the most significant of all of them. The near surface wind basically vanished in step with the surface cooling. So if you look basically at that 0 mark where sunset happens, the temperature starts dropping and the wind speed drops as well. This is a classical nocturnal inversion observation. So jumping over to Princeton, where you do have that terrain difference, I wanted to show how that is represented here. So you have this elevation difference. However, it kind of does the opposite of what happened at the other location. So you have these lower points. While they are significantly lower than each other, you do not have that notable impact. And a lot of that has to do with the relative elevation. With the Western Kentucky University farm, it is that low-lying point is truly a low-lying point. It's not just a lower elevation. So it was able to have larger cool air drainage, whereas the terrain in Princeton is a bit more sloping, and so the lowest elevation, that PNCC, while it was a low point, there was still lower points to be had, and so the inversion frequency is pretty consistent across the board. However, that higher elevation did see fewer overall inversions. So focusing back on the Western Kentucky University farm, I wanted to bring up land atmosphere coupling. And so this is basically the setup for a drought. Leading up to this, we had a week of fair weather brought on by a strong land atmosphere coupling. There was a Bermuda high that extended west of Mississippi, and it led to a very southerly flow at the surface. It was the perfect setup for warm days and cold nights. And unfortunately, it was set up for drought as well. So we had these warm daytime temperatures, which as a result led to increased saturation vapor pressure and saturation vapor pressure deficit, an increase in potential and actual evapotranspiration, which as a result led to a depletion of soil moisture and plant wilting, which led to the decrease of actual evapotranspiration, which led to the loss of atmospheric water vapor. And then it just kept feeding. It was a negative feedback system. And until there was a precipitation event to basically wipe it all clean, it just kept going and going and going. And the moisture was being repeatedly depleted. And thankfully, I believe we did have a storm system that moved through afterward that replenished the moisture into the system. But this was a very classic example of how quickly drought can happen in Kentucky. So looking forward, some of the future work that we hope to do, we have 3 portable tripod platforms for IOPs, or intensive observation periods. So we are able to deploy these out into different areas and get even denser observations across the farm scale. We are hoping to have expanded sensor packages and data products. We are hopeful to have even more customized data dashboards. That is where some of you will really help us out, because we need to know what kind of data needs to be brought into a dashboard, what kind of different data sources and so forth that we can bring together to be useful. We want our data to benefit the Commonwealth and to benefit research. So anything that you are able to pass along would be incredibly helpful. And that goes for the further development of the soil products and metadata as we move forward. So with that, I will end and I will welcome any questions.
Thank you very much, Megan. That was great. And I know a whole lot more about the Kentucky Mesonet now. So happy for Megan to take questions. If people want to just chime in on Zoom, feel free. If you want to add them into the chat. Megan, I saw that Jimmy Henning had one added in there. Do you have a grid of what sensors are present at which location?
I do not have a grid, but we have a handful of maps that lay out visually what stations have what on them. If that's kind of what you're getting at, or do you mean something like a table of some sort?
Just a way to know where to find the ones that have soil moisture sensors, for example.
Yeah, so if you, just from our main website, as you're looking through, there are different areas that focus on soil on our website. And so if it's on the website, it's a station that has soil monitoring. But we can work to make that a little bit more obvious.
Megan, you got a question from Tim Phillips here. Any plans to monitor ozone, carbon dioxide, sulfates, or NOx?
So we don't at the time, only because those sensors tend to be very power hungry. And so as a result, most of our stations are solar powered. We have a handful that are AC powered that could possibly handle that, but everything else, I think those kind of sensors would completely deplete our batteries. I know our Boone County station is located next to a Kentucky department. I'm not sure what the department is, but air quality. That they have a housing next to our station a little bit away. So we don't have it, that's not monitored through our network, but it is available out there. And then,
Okay, and Ray asks, are most Mesonet stations maintained as grassland below the station? Are any maintained with bare soil beneath the station?
so that is one thing that we have, especially as we delved into soil monitoring, one thing that we really debated, because in particular, the Oklahoma Mesonet, they have bare soil plots as well as sod plots. So we chose to move only with sod, just because we are not able to get out to our stations frequently enough to keep a bare plot bare. We would have to basically be there weekly in order to maintain that. So we chose to stay with what we knew we could handle more than anything. And we didn't want to risk bringing in a bad data set. So no bare soil.
So Megan, when you have the station at the North Farm, would you ask us to keep it mowed at a certain height? So it's not just mowed once, 3 times a year? Or
I mean, if somebody is available to help maintain, we will not say no. We appreciate whenever there are the local people that are able to help maintain, more than anything, just because keeping a regular eye on things really does help. So with that, for an example, if somebody would be able to maintain or help maintain a bare soil plot, that is something that we could consider. And that's part of the reason we wanted or I wanted to come talk to you, is because of all of these little things that are possible. It's not just, this is a Mesonet station and this is what we do. There are those little things of where we could deploy more soil sensors, or we could do different types of soil sensors. And so it's definitely a conversation to be had. And I'd be happy to have it.
great, thanks.
I see we put one in the chat. Nice to see Kentucky Drought Early Warning System project. What kinds of drought index are applied to this warning system to support different purposes, including meteorology, hydrology, and agriculture?
So we do not employ any direct drought indexes. We are only providing the weather data to the system. I know that our data does go into the US Drought Monitor whenever people are making the decisions for contributions there, as well as there's the Palmer Index and some of those standard indexes that are reference the standardized precipitation index and so forth. So while we don't have any of those directly calculated, we do use them. I'm not sure if that answers your question, but I'm happy to again have a further conversation with you about that.
She says thanks. Megan, what about lightning? Do you guys do anything with lightning?
We do not. Unfortunately, lightning systems are incredibly expensive. I had no idea how expensive they were until one county asked for one, and we started looking into it. And it's just not something that we are able to sustain.
Anything else from anyone in the crowd? Well, Megan, hearing none, you did end up with 41 viewers here today, so you got a good crowd for 3 o'clock on a cold Friday when campus is closed. So thank you very much for joining us. I think people learned a lot about the possibilities, and hopefully as the new station goes up on the North Farm, people will be thinking about how we can best utilize it and new collaborations that we might be able to form with you and the Mesonet in general.
Yeah, absolutely. And again, I welcome anybody to get in touch with me or to get in touch with Dr. McCauley, who can route you to me. I'm I think that there are a lot of possibilities. And as I showed in my presentation, we have a lot of UK partnerships that already are existing. And so I know that you're all a great group to work with, and I'd be more than happy to talk at some point.
Great, Megan. Thank you so much. Enjoy the rest of your Friday, everyone. Stay safe and stay warm.